Okay, today we're going to talk about the adrenergic drugs. To understand adrenergic drugs, you really need to understand the nervous system. So we're going to do a diagram of the nervous system, just an overview. I'm new with using this pen, so it's a little, takes some getting used to. My handwriting is not that bad. Okay, nervous system. Okay, so our nervous system consists of a central and a peripheral nervous system. So here's our central nervous system and our peripheral. Okay, so our central nervous system is going to consist of our brain and our spinal cord. Our peripheral nervous system, much more than that. You have the autonomic, which is the automatic. Means it's things that do automatic. You don't have to worry about doing it on its own. And then you have the somatic, which is your skeletal muscle. And that is voluntary. Okay, so if we continue to look at the autonomic nervous system, it is split up into parasympathetic, and sympathetic. Let's make this a little bit bigger. That's nervous system and nervous system. Okay, so your parasympathetic is your cholinergic. Your parasympathetic is your adrenergic. See how this comes all in to play here? This is your adrenergic. So there are 3 neurotransmitters that we're going to talk about. Okay. These 3 are norepi, epi, and dopamine. These neurotransmitters are also called catecholamines. Or they are called adrenergic agonists. So, whoa, oops, let's make that bigger again. Adrenergic agonists. Okay, So we're going to be talking about stimulating these neurotransmitters. Okay, so what happens when we do stimulate these transmitters? It sets off the fight or flight response. Okay, so these three neurotransmitters right here, the norepi, epi, and dopamine, they are responsible for the fight or flight response. So we're going to talk about the fight or flight response and in more detail what these receptors do on the next slide. So let's do our fight or flight. Okay, so that involves a lot of things going on, right? Let's put this, there we go. Whoa, okay. It's going to involve alpha adrenergic receptors, it's going to involve beta adrenergic receptors, and then dopamine receptors, which they call, let's make this a little bit shorter right here, which they call dopaminergic receptors. Dopaminergic. If I can get an M on here. This pen does not like me. There we go, an M. So dopaminergic receptors. Okay, so the dopaminergic receptors are only stimulated by dopamine, okay? Your alpha receptors, you have alpha 1s and alpha 2s. Your alpha 1 is the one we're going to talk about first. So your alpha 1, it causes vasoconstriction, causes dilation of your pupils, be nice if I could spell. Okay, so that you can see, stimulates the central nervous system. So CNS stimulation. This allows you to stimulate the brain so that you can be alert and you can concentrate. Okay. And then it also causes constriction of your bladder. Or rather, your urethra. because you don't want to have to pee in the middle of trying to fight somebody or flee, right? So then you have, alpha 1s will causes vasoconstriction. So you have good blood pressure, good blood going to where it needs to go. Dilation of your pupils so you can see in order to fight or flee. Then you have CNS stimulation, which allows your brain to be alert and to concentrate so you can fight or flee. And then constriction of your urethra so that you don't have to run to the bathroom in the middle of all this. Okay, and then you have alpha 2s. Your alpha 2 is interesting because it actually will reverse sympathetic activity. So you can't be, it's not good for you to be in a sympathetic nervous system stimulation all the time. You don't need to be in fight or flight all the time. So we have a mechanism intact. We have alpha 2s that when stimulated, they actually inhibit. So they inhibit our sympathetic response. So I'm going to put that here, inhibit. When it's stimulated, it inhibits, which makes it very different than everything else. Okay? Now let's talk about your beta 1s. Okay, so your beta adrenergic receptors. You have beta 1, which is your heart, right? So let's see, it's going to increase contractility. This is the force of contraction of your heart. It's going to increase your heart rate. So blood gets pumping to where it needs to go. And it's going to increase renin secretion. Why is that good? Well, you may remember from pathophys that renin actually will stimulate vasoconstriction, and it stimulates the kidneys to uptake water, so to hold on to water. So it increases blood pressure, right? So you want good blood pressure, you want good perfusion when you have to run somewhere or you have to fight somebody, right? Gives energy to our muscles. Okay, and then we have beta 2s. These are our lungs, or they're in the lungs. So they're going to cause bronchodilation. Because we want to be able to get a bunch of air into our lungs so that we can run or we can fight, okay? It increases glucose. This is released from the liver, which gives us energy to fight or flight. So we'll say it's released from the liver. Okay. And then lastly, you have the dopaminergic receptors. They all cause arterial dilatation, so the arteries to dilate. I'm really trying to write this. Good gracious. So you have arterial dilation, of your kidneys, of your heart, your brain, and your GI tract. Okay? So it helps increase the blood supply to these areas so that we can stay alive while we fight or run. Okay? So there's a little overview of that. Okay, so we're going to look a little bit more in depth of the specific receptors. So we talked about, okay, so adrenergic drugs. So what do adrenergic drugs do? They're going to bind to the receptor sites and stimulate the effects of catecholamines. So we said, well, we just talked about what the effects of the catecholamines are, right? So that's the effects of norepi, epi, and dopamine, okay? If we're stimulating alpha adrenergic receptors, okay, we're causing the vasoconstriction, we're causing the pupil dilation, we're causing that CNS stimulation and that urethra constriction, okay? If we are stimulating alpha 2 adrenergic receptors, then we are going to reverse the sympathetic activity. We're going to prevent or inhibit the activity of the fight or flight, okay, response. Okay, so we're going to inhibit. Let's write that here. So we're going to inhibit. Okay, remember these are the catecholamines. My goodness. Let me make this bigger and maybe it'll stop doing weird things. Or not. Okay. If we stimulate the alpha adrenergic receptors, then we are going to cause the increase in contractility. We're going to cause the increase in heart rate. We're going to cause a renin secretion, okay? If we stimulate the beta 2 adrenergic receptors, we're going to cause bronchodilation, okay? We're going to cause glycogenolysis, which is the release of glucose from the liver. Doesn't like my A's for some reason. Get this bigger. Okay. And if we stimulate the dopamine receptors, then we're going to increase the blood supply to the kidneys, the brain, the heart, the GI, okay, via dilation of the arteries, in the renal arteries, the mesenteric arteries, the coronary arteries, and the cerebral arteries. Okay. So when we stimulate, okay, we have these receptors, we have these neurotransmitters, okay, epi, norepi, and dopamine. They are actually produced in the sympathetic nervous system and stored at the ends of nerves. So you have your nerve that looks like this. So you have a little nerve here. Y'all remember this? And you have, so here's your little neurotransmitters here. They just hang out right here at the ends of nerves, okay? When they are stimulated, okay, when a nerve is stimulated, they release these catecholamines, these neurotransmitters, okay? So this is stimulated. So they're released in the synaptic cleft. Y'all remember that's like the space, okay? To hit on an organ, okay? So we're going to say our end organ is right here that we want to stimulate here. So it goes here and it stimulates this organ, okay? So when a catecholamine is released, it's released from the end of the nerve, goes to the receptor on the organ, causes an effect, okay? Now the action of the catecholamine can be stopped by either being scooped up by enzymes, okay? So there's, let's make this a different color. So we can have enzymes that scoop it up and put it back where it needs to go, okay? So scoop it up, put it back where it needs to go. Or it can be metabolized. It is metabolized by these two things right here, okay? So MAO and COMT, okay? So it's either or. So they're either going to be scooped up to be reused, or they're going to be metabolized by MAO or COMT to be dissolved, to be gone, okay? Which is important when you talk about MAOI inhibitors, okay? They're actually preventing these neurotransmitters to be metabolized. So it's kind of interesting thing. All right, so when we look at the mechanism of action, let's look at this. So the adrenergic drugs are similar to or mimic the effects of the catecholamines. They work in the same way that endogenous catecholamines work. Endogenous means what our natural thing does, what our body does naturally, okay? So they mimic the same effects. So when we give a medication, it's to do the same thing that catecholamine would have done in our bodies, okay? We're just giving it some extra, okay? Now the adrenergic drugs can induce a response at the synaptic cleft. They can either do direct stimulation, which means it binds directly to the receptor. It can cause indirect stimulation, which means it causes release of the actual catecholamine from the nerve endings, okay? Or it can do both. So it can do both indirect or direct actions. So it can bind directly to the receptor and it can cause release of the catecholamines. An example of an adrenergic drug that does both is ephedrine. Just imagine ephedrine increases your heart rate and it increases your blood pressure, right? In fact, it used to be used as a diet medication. In fact, I think it still kind of is, because it increases your heart rate. It makes your body work more, right? So thus you burn more calories, so to speak, but it kills your heart in the meantime. Non-catecholamine adrenergic drugs, their structure is different than the catecholamines, and in general, their duration of action is longer. So they're going to last a little bit longer than our normal catecholamines would in our body. But the action is similar, not super close, okay? But it is similar. So an example of this would be like phenylephrine, okay? So adrenergic drug like Sudafed, pseudoephedrine, okay? And then a non-catecholamine adrenergic drug would be phenylephrine. So you're not going to have quite those side effects that pseudoephedrine would have as opposed to phenylephrine. So when we're talking about adrenergic drugs, contraindications would be severe hypertension, right? Because stimulation of the adrenergic system causes hypertension anyway. So if we already have hypertension and then we give a medication that causes more hypertension, we're going to cause some serious problems, right? And then patient teaching, avoid over-the-counter medications or herbal meds without getting approval by your doctor or the prescriber, okay? Because we talked about there's a lot of medications that are over-the-counter that already have adrenergic stimulation properties to them, as well as herbal meds that will have that, and we don't want overstimulation of the sympathetic nervous system.